This is a training video in how to use the lifting equipment for CERT to get equipment, supplies, and meals to the upper floors of our independent living apartments in an emergency. In an actual emergency, such as an earthquake, it's quite likely that the power will be out to our independent living units. And because that power is out, there will be no elevator service. Our elevators have a fail-safe mode that will take them to the bottom floor and open the doors if there's no power, but they cannot be used thereafter. They cannot be used to go back up to upper floors. So getting equipment such as CERT supplies like cribbing blocks or first aid kits or even meals to the second and third floors of the independent living buildings will be a real challenge. So in this presentation, what I'm going to do is show you a human-powered system that we can use to enable us to get equipment, supplies, CERT supplies, and meals to the upper floors quickly and reliably without the need to carry these items up the stairs. We will look at the steps that are needed to assemble and operate the various parts of the system. We will look at the teamwork rules that are required to operate the system safely. And we will look at how then we can remove and store the system once we're finished doing lifting items from the ground to the various floors. The basis for this device is a rope and pulley system that you see in the picture on the left-hand side of this slide. There is a pulley that's mounted underneath the roof overhang on the third floor, and it's connected by means of a rope to two people on the ground who will facilitate the raising of the load to either the second or the third floor. Notice that we have two people on the upper floor and two people on the ground to make the system work. The equipment that we need, Vincent Foresta has kindly installed eye bolts at the appropriate places on our property in order to allow us to use this system. And the required parts are shown on the right. At the bottom, you see what one of the eye bolts looks like on the third floor overhang. On the right, you see that we have a rope system that consists of a top hook, a pulley, and a carabiner on the bottom, one of the bottom ends of the rope. Also included in the kit are several extra carabiners that might be needed to fasten things to the bottom of the rope, some lifting web straps that might be needed to wrap around things or wrap through holes in carts or containers, and finally a guide pole which has a lanyard on one end to enable it to be securely held on the third floor, and it has pins on the other end which allow you to grab a hold of the rope or grab a hold of the top hook and put it through the eye that's on the overhang. The eye bolts that we have on this property are located on the third floor overhangs. There's one just opposite the walkway outside of apartment N359. There is one just outside the walkway associated with D329 apartment. And finally, there is one just outside the walkway for apartment L340. As you probably know, because of the way our elevators and our buildings are shaped, the only way to reach the third floor of the L building is through a special arrangements, and that's why we need two eye bolts on that side, whereas on the swimming pool side of the esplanade, we only need one in order to reach every apartment on the second and third floor. The steps that are required to install the rope and pulley system are as follows. The first step is to take the rope assembly and the guide pole to the third floor. That'll require two people taking these things up the stairs. They're very light. They don't require a lot of lifting to get them up, but it will require that people hike up 2 flights of stairs. Once they're upstairs, they can unfurl the rope and lay it out on the ground on the walkway of the third floor, and at that point it's a good time to check it for nicks or cuts or kinks or things that might cause the system not to work well. So you can see that it's laid out on the ground there, and the two lines are parallel to each other. The next step is to use the guide pole to hook the upper hook on the rope system through the eye bolt. The reason we use that guide pole is so that you don't have to lean far out over the railing in order to do this connection. It's fairly easy, and the pole is well long enough to make this possible and safely, so you don't have to hang your body out over the railing, or you don't have to stand on the railing or get on a ladder to hook it up. Step number 4 is then that once it's hooked to the eye, then the two free ends of the rope are carefully lowered over the railing and down to the two cert members who are on the ground. Once that happens, then we are ready to start attaching things to the carabiner end of the rope and lifting them to either the second or the third floor. So the first step is to attach the carabiner end of the lifting rope to the load that you want to lift. We have provided some yellow straps that may be helpful to do this connection, and there are also some extra carabiners that allow you to hook onto things. And you should probably use more than one attachment point. When you connect things using that, you want to make sure that the load is balanced, that it's stable, and it doesn't tip, or it doesn't have the possibility of coming unfastened while it's being lifted into the air. Once that's in place, then the next step is to lift the load just a few inches from the ground by pulling on the free end of the rope, the other end of the rope that's coming down from the pulley. And the reason for that is to make sure that the load is stable on the rope, it's centered under the pulley, and it doesn't swing back and forth like a pendulum. Once that's in place, then you're ready to do the lifting. And the first thing to do there is, of course, the two cert members on the ground should communicate with the two members on the upper level to see if they are ready to guide the load as it is being received. So once everyone agrees to start the lifting, then the two people on the ground should step back from underneath the load and pull down on the lifting rope to raise it to the second or third floor of the building, whichever is needed. As the load is being raised, if it's large enough in size that it could scrape against the side of the building, the upper team should use the guide pole to push the ropes away from the building, and that should provide additional clearance to make it possible for the load to get up without scraping on the side of the building. When the load reaches the correct floor, the second floor or the third floor, the upper team should reach out and pull the load in over the railing. They can use the guide pole again as a kind of hook to do that. It may require that the lower team provide enough tension to keep the load from falling, but enough slack in the system to allow the upper team to lower the payload over the railing and put it down on the walkway so that they can unfasten it. So once they have it down on the floor of the upper walkway, that upper team then should ask the lower team to give them a little more slack tension in the rope so that they can disconnect it from the payload. Once the payload is free from the rope, the upper team then should guide the lifting rope, the end with the carabiner on it, back over the railing to assist its travel to the ground so that it can be used for additional payloads that may need to be raised. Here is what the communication process should sound like. The lower team should declare to the upper team, we are ready to raise the load, we're ready to do the lifting. And the upper team need to say, yes, go ahead, proceed to lift, we're ready to receive the load, the payload that you're bringing up. Then the lower team can say, we're now lifting. And of course, the upper team, once the load gets to a place where they can grab a hold of it and pull it in over the railing, they can say, hold in place, no need to lift any higher, and so forth. Once the upper team has gotten it safely over the railing, they may be asking the lower team to provide some easing on the rope so they can lower it down to the floor on the walkway. And of course, the lower team then will say, we're easing the tension. They need to stand by, though, so if something happens, they still will be able to grab a hold of the rope and make sure that the object being lifted doesn't fall. Finally, when the upper team has the payload removed from the rope, they will be in a position to lower the rope. So they will say, we're ready to lower the rope back down to you. And the lower team then can feed the rope upward so that the carabiner end can come down. That may require that the upper team actually pull down a little bit on the rope so that it can go down. If the weight of the carabiner is enough, it'll it'll go down automatically. But if not, they can feed it down carefully as they hold it over the edge of the railing. Some important rules for the safe operation of this system. The first one is that good communication is really the key to safe use of the system. And I can't emphasize enough that you need to be able to communicate with the two teams, the team on the upper floors and the team on the ground. It's a good idea to wear your gloves, your goggles, and your helmet while you're using the rope and pulley system. Those are probably in your CERT Go kit. If you find that you cannot safely get the load to the upper level, if it's too big or too awkwardly shaped or something goes wrong, you should be prepared to lower it back to the ground and try something else, or taking it into smaller pieces before you raise it using this system. This system is not designed to lift humans, and you should never use it for that purpose. It is not safe to be using this to lift people up and down in our buildings. In fact, the load limit for this system is 80 pounds. The truth of the matter is the load limit is probably limited by whatever the weight of the person who's pulling down on the rope. If they are pulling down with more than their weight, then they're actually raising themselves up in the air rather than pulling the load up as it should be. So we're going to limit this to 80 pounds. That still allows for a lot of equipment to be lifted in small bundles to the place where it needs to be lifted. All of our cribbing containers are much less than 80 pounds. Even the shopping carts that we use on campus, the plastic ones are in the range of 50 pounds, and the metal ones are in the range of 75 pounds. So they fit under this limit. So if you wanted to raise those, you could, but that might be hard work. Finally, if you are operating at night, it's a good idea to keep the payload illuminated with a flashlight as it is lifted, so that you can see where it is and know when it reaches the top and when it's time to stop pulling down on the rope. For those of you who remember the Roadrunner cartoons from your youth, you probably remember that it never turns out well for the coyote, particularly if he stands directly under the load being lifted. So my recommendation is never, ever stand under a load that's being lifted. If something goes wrong and the load falls, you don't want it falling on your head. The steps then required to remove the rope system, to take it down once you're finished doing the lifting that you need to do. You can use the people on the upper level can use the guide pole to pull the rope system back onto the third floor walkway and even stretch it out a little bit. Once they've got it on the floor, then they should use the guide pole to unhook the rope system from the eye bolt. It's kind of the reversal of the process that they use to set it up. And finally, then the entire rope system should be laid on the floor of the walkway and coiled up so that it can be returned to the CERT room or taken to another one of the locations where there may be a need to raise equipment or supplies to a second or third floor. If you coil the rope properly, the rope will be ready to deploy very quickly at a later time. If you don't, it'll be all tangled up and it's a mess. So if the rope is coiled properly, it will be easy to redeploy it without tangles or kinks or problems. I recommend the double butterfly coiling method that's often used by climbers. And here's a video that shows you how to do that.
So I normally coil my rope using a butterfly coil over my shoulders. So here I have my gym rope flaked out on the ground, and with a rope this short, I'll normally start with both ends, but you can always just start from the midpoint, or you can start from one end of the rope. And what I'm going to do is I'm going to take both ends of this rope in one hand and pull out about an arm's span of rope here and drop that over my shoulder. And then basically I'm just going to do that again until I reach the end of the rope. All right, cool. So now I have about an arm span of rope left. So what I'm going to do is take these coils off of my shoulder. And I'm going to wrap this up the way that I normally do for storing my ropes. So I'm going to hold the coils in one hand here and then take this loose end of rope and wrap it around the coil. And I'm going to keep going, keeping that first wrap on the bottom. Kind of just locks it into place, keeps it snug. Then we're going to get to about here, and I'm going to go ahead and pass a bight of rope through here, through the coils, and then take the end, which has my marked midpoint, and pass that through the bight. There you go. So this is a really neat way to store, this clean way to store your rope. And then you can always just clip a carabiner through here if you're hanging your rope up. And this is generally how I will store my rope. This is a modified version of the butterfly coil.
Of course, our rope will have the pulley system at that bite at that top end, but it still works exactly the same way. Our facilities team has installed the eye bolts in the 3 different places that are required so that we can reach every floor of every independent living part of our buildings here at the terraces. We can use the same rope system for each of the various locations, each of these 3 locations, or we could purchase additional rope systems if we have more than one lifting team that is trained. The components of the system are shown here in this slide. And as you know, a chain is only as strong as the weakest link. And the weakest part of this system is the zinc-plated quick link that you see on the right-hand side, second from the top. It has a capacity of 750 pounds. And so this system has a static test load of about 700 pounds, even though we won't probably ever load it up to that because we have no way to pull down 700 pounds. It would take more than 2 or 3 people to do that. There is now time for questions about this training video, and I would welcome the chance to answer those for you. If I'm not present when you watch this video, perhaps the person running the video can help you with those answers. If not, contact me, Terry Schaup, at my apartment, L238, or call me at area code 408-515-2877. Thanks a lot.